Thank you very much, Stefan, for the introductions. Hi there, guys. I'm Henna Morkel. Thank you for joining us on this geospatial technology webinar today on the DJI Enterprise Matrice 300. We are very excited to have you here. And let me just share my screen with you. Right, so today's topic is hands-on the Matrice 300 and the new DJI surveying and mapping payloads. So let's get into it. So in mid-October, DJI Enterprise released the ZenMuse L1, stands for LiDAR, and P1 photogrammetric camera series. I like to call them the powerhouse payloads. So you can see the P1 is a 45 megapixel full frame photogrammetric camera. They are both fully integrated to work with the advanced Matrice 300 RTK drone. These new payloads opens up a wider range of applications with survey grade accuracy capabilities to the market. So let's have a look at the ZenMuse L1 LiDAR payload. So for practicality, I did not include videos on this session. I only have screen grabs. That is, can you please mute yourself? Okay. So this is just screen grabs from the premiere video, the release video of the L1. Please have a look at the full video in the description below this highlight reel. It really is truly a good indication for you of how this sensor works and what it's capable of. So if we look in a bit more detail, the slogan there, instant clarity, superior accuracy. So the ZenMuse L1 integrates a Livox LiDAR module. Company is a separate company, Livox, that partnered with DJI to create this sensor. A high accuracy IMU. For those of you that don't know what an IMU is, it's an inertial measurement unit. So it aids in the positional accuracy and attitude of the aircraft and sensor as it is being surveying and the laser scanning. And this is combined with a camera, a 1-inch CMOS camera on a 3-axis stabilized gimbal. So when used with the Matrice 300 RTK and DJI Terra, which is DJI Terra's processing software, the L1 forms a complete solution that gives you real-time 3D data throughout the day, efficiently capturing the details of complex structures and delivering highly accurate reconstructed models. So if we look at some of the key features of this payload, as mentioned, it's integrated LiDAR, RGB camera, and high accuracy IMU. If we look at the efficiency, so it's a high efficiency because of the M300 can fly for 50 minutes. You can cover about 2 square kilometers in one single flight, or 200 hectares. It's got a high degree of accuracy. You can see there vertical 5 centimeters, horizontal 10 centimeters. Then on the laser point rate that you're getting from the laser, it's about at 240,000 points per second that the laser beam is shooting out while it is flying and mapping. This LiDAR sensor also supports 3 return, so it can hit the top of the tree canopy, the middle section on the branch, and the ground at the bottom. So you can, in highly vegetated areas, get a very good representation of your ground model, your elevation model. This is different than photogrammetry, where you only get what you see is what you get. You will only get a point cloud, points elevation data from the tops of the tree canopy. Right, then it also has an IP44 ingress protection level. So the sensor is actually robust and rugged. It can withstand solid objects of 1 millimeter and upwards, and also splash resistance from all directions, water resistant from, Then on the detection range, 450 meters at 80% reflectivity. So this range is all to do with what you are surveying, what you are mapping on the ground. If the features do not have a high reflectivity value, this range might drop. But yeah, that's the specified range at 80% reflectivity. Then as well, a very nifty feature that this sensor with the drone has is a point cloud live view. This actually enables you to see on the fly, on your remote controller, the point cloud being generated as the drone is flying its flight lines and capturing data. We'll see this in more detail shortly. So visualize your data as you fly. Livebox LiDAR supports 3 returns, and it's got 2 scanning modes or patterns, a line scan mode and a non-repetitive petal scan mode. So if I just explain to you in terms of the scan modes, on the left we've got the non-repetitive petal scan. If you see there, it looks like a flower being built there. It scans in a circular pattern, this petal shape. And on the right, you've got the linear line scan pattern with 2 options depending on your requirements. Right, then everything in view. So coupled with this LiDAR sensor, laser sensor, is a 20 megapixel resolution RGB camera. So it's a 1-inch CMOS mechanical shutter, so ideal for photogrammetry as well. It's the same camera basically that's in the Phantom 4 RTK. So in one single flight you can produce an orthophoto as well as your laser point cloud, and also colorize the laser point cloud from your images. High accuracy. So the IMU that's integrated and built into the sensor delivers high accuracy for the positions of where the sensor was looking while it was scanning a laser beam out or taking photos. This instrument as well aids in fusing the GNSS or the GPS data, the IMU and the RGB images together to create data fusion. Here we have an example of the point cloud live view. So you can see there on the remote controller, as the drone is flying the flight lines, it's actually showing you the resulting scan data in real time, which I think is amazing. With this you can also do real-time measurement. So you can actually, you'll see between this canyon from the left to the right, this guy is measuring on the actual data on the remote controller a distance between those 2 peaks of the canyon of 126 meters. Then here you've got a true colorized point cloud. So you can see it's a dense point cloud, lots of penetration there. Alright, and then we move on to DJI Terra. So your one-stop post-processing software. The DJI Terra, this enables you to, instead of with some IMU systems on LiDARs on drones, you have to post-process the position data in third-party software, Planex, and so forth. POSPAC, but with this system you can actually do everything in one software, namely DJI Terra, which fuses the IMU and GNSS data for your point cloud with the raw point cloud and visual light calculations, in addition to conducting positional data calculations, so you can effortlessly generate and your reconstructed models and accuracy reports. Right, and then some application industries for this sensor: topographic mapping, architecture, engineering and construction, surveying, emergency response, law enforcement, energy and infrastructure, and then of course agriculture and forestry management. Here's a very nice case study. Again, this is just a highlight reel, but please go and have a look at on the hyperlink here below this video, at the full video. This was done in Indonesia for a company called Pertamina. So what they're the biggest geothermal power plant in Indonesia. They're basically using this LiDAR to map their power line distribution lines to see where vegetation might be encroaching on the lines, to go and do maintenance and cut down trees and these kind of things, as well as getting topographic data for new distribution line planning. Right, then the estimated shipping date of the L1 is set to be in January 2021, and I can provide you with budget pricing of around 300,000 Rand or $20,000 US. Alright, so let's move on to the ZenMuse P1 photogrammetric payload. Here's the introduction video. Please go and have a look in the description below of this recording. You can click on the hyperlink, which will show you the complete video of all the smart features that this amazing drone and payload has. If we look at the specifications, so efficiency through flexible full-frame photogrammetry. So the P1 integrates a full-frame sensor with 3 interchangeable fixed focus lenses on a 3-axis stabilized gimbal as well. This camera is specifically designed for photogrammetry flight missions, and it takes efficiency and accuracy to a whole new level. If we look at some of the key features of this payload, so accuracy without ground control points is specified as 3 centimeters horizontally, 5 centimeters vertically. You'll see I've put some red asterisks there, and just a note, it's always recommended to use at least 4 to 6 ground control points or checkpoints when doing aerial survey, especially if you want to do volume calculations or ground truthing. You want your elevation, you want to be sure of the ground elevations. You will always need some ground control points or checkpoints. The RTK functionality just reduces the amount that you have to actually place out in the field. It's a 45 megapixel full frame sensor. If we look at the efficiency, also very highly efficient, mapping about 3 square kilometers or 300 hectares in one single flight. It also has smart oblique capturing function built in, which I will explain in just a couple of slides. It's got a global mechanical shutter with a shutter speed of 1/2000th of a second, so that you won't have a blurry or smudgy image. The lens opens up very fast, and this also enables you to take in all of the light, crisp, clear pictures, images. And this enables you to fly at higher speeds while still getting very crisp and clear imagery. This payload has got an IP, sorry for that, 44. It's not. It's an IP40. It's an IP4X ingress protection, which means it's also been tested and put through the tests to be withstand objects of 1 millimeter and up, but it did not do a water resistance test. But obviously you don't want to fly, even though the drone is capable of flying in the rain, you don't want to fly in the rain for photogrammetry because you're going to get water droplets on your camera lens, so your images are going to not be good. Then it's also got time sync 2.0. Now I'll explain just now in the next slides what time sync 2.0 does at a microsecond level. So the full frame CMOS sensor is more than 5 to 10 times more efficient compared to Phantom 4 RTK for both ortho and oblique mapping missions. It's got a 4.4 micrometer pixel size. It takes images at every 0.7 second time intervals, which you can obviously adjust. And what time sync 2.0 does is, from this picture here, is that it synchronizes with the flight controller, the RTK modules, which are these two round at the back antennas of the drone, the gimbal and the camera. So to the center of the camera lens, it synchronizes the time and the corrections of all of this at a microsecond level. So it's very accurate. This is also a low noise, high sensitivity and high dynamic imaging system that extends your daily operation time by about 10%, which means you can start flying earlier in the morning with less light, and you can still be flying at when sunset with still some sunlight. You'll still be able to get good exposures on your images. So flexibility to capture it all. As mentioned before, it's multiple fixed focus lens options. You've got the stock standard that comes with the payload, 24 megapixels. Then you have 24 millimeters. Then you have the 35 millimeter lens and as well the 50 millimeter lens. Now these lenses just differ in the field of view that they can see, but the 35 millimeter lens is mostly recommended for normal surveying and mapping operations. Right, so coming back to the smart oblique capture function. So you can effectively cover 7.5 square kilometers or 750 hectares in a single work day with the P1. This elevates your efficiency. With the oblique photography mission using smart oblique capture function, where the gimbal automatically rotates to take photos at different angles as needed. So if I play this animation to show you there's the area of interest we want to get mapped, there's the flight lines of your flight plan. So the drone, this P1 payload as well, now will, as it's flying, only take photos in the north, east, west and south direction. It actually oscillates on its own axis like this, and you see there at the top it didn't take photos in that area. So this increases your efficiency to only have images in the areas of interest which you want to post-process, so that you don't need to have all of these redundant images outside of your working area, which you don't need to process. And then this obviously increases your efficiency with about 20 to 50%. It also has a built-in fieldwork report, so you can verify your data quality immediately post-flight by checking the position data and the number of images acquired, as well as the RTK and position and accuracy of each of those images. This drone will obviously be connected with the DRTK2 mobile base station from DJI as well. So real-time mapping. So coupled with the DJI Terra software, you are able to do real-time mapping of large areas over a site. And if you have the network set up correctly on your site, you can have with Flight Hub, which is another software from DJI, actually in a boardroom somewhere outside of the actual site, you can relay the images, real-time mapping on the fly to that office with this drone. You can see there, it's capturing images and stitching them together on the fly, real-time, and relaying it back to an office. So similar applicational industries: topographic mapping, cadastral surveying, AEC, natural resource management, geological inspections and investigation, and as well as disaster site modeling. So one use case for the P1, 2D ortho map. You can see here the specifications of the mission. It was flown with the M300 RTK and the P1. Covered a 1 square kilometer or 100 hectare area with a GSD or ground sampling distance, which is your resolution of 1.5 centimeters. The amount of images that it took, 3,100 geotagged images with some checkpoints. The root mean square area georeferenced down to 4 centimeters, and the flight time was 33 minutes. Then on another interesting use case in the Wusha Canyon in China. Just some background on this use case. So the Jinsha Cave, located in the Wusha section of the 3 gorges of the Yangtze River, the water level at the Yangtze Cave has risen by more than 100 meters after the impoundment of the 3 gorges reservoir area, and fluctuates by 30 meters every year. So you can imagine that sheer rock cliff face is getting deteriorated and eroded over time. So the body that is actually governing this, the safety of the river channel, opted to use drone technology for further inspection work. I just play you that short video. You can see there's guys hanging off of trolleys and things, inspecting it. That's the traditional, the faults and so on, the traditional method, which obviously comes with a high risk factor. So the traditional geological survey method by SRT single rope lifting technology required operators to climb the corresponding area on on-site investigations and inspections, which is difficult and has a high degree of risk. This use case has got high resolution requirements. So for geological inspections, they need to know if the rock mass, the cracks are moving at a millimeter level. So the data must be captured very close to the wall. So they also need high precision. So in order to compare the cracks before and after, if a piece of rock maybe broke loose, so it's necessary to ensure the consistency of the two instances of mapping and modeling the surface. Then you also needed a high degree of resolution. So you've 45 million pixels. The resolution down to 1.7 millimeters was obtained by flying 20 meters from the rock face. So you can see individual cracks. Here is a quick animation that just shows you the high degree of detail that you get with the P1 camera. This camera you can obviously also use on high walls to do similar inspection work for fault line detection. You can see there measures that crack there. You can see the reinforcement wires as well. Very high degree of detail. Now if you zoomed out, you can see all the photo stations, those green blocks of this model. Right, then if we conclude with the P1's estimated shipping date, is the full frame aerial survey camera will be in March 2021. For budget pricing purposes, it's priced at 150,000 Rand or 10,000 US dollars. Okay, so now we move over to the next portion of the webinar, which was the hands-on with the DJI Matrice M300 RTK drone that I recently worked with. So I went out into the field and did some power line inspection. This was done with the H20T camera for this drone as well, which is a inspection and more law enforcement, public safety kind of payload. It's got a very high degree of zoom capability, a thermal camera, as well as one laser distance measurement to tell you what the coordinates are of a certain object. So again, here's just a quick animation of taking off. There on the left you can see the RTK2 mobile base station that's sending the positional accuracy and flying in RTK with the drone throughout the mission.
Hey, no, if I can quickly interrupt there, if you can go one slide back.
Yes.
I think what's very important is this drone's ability to take off right next to a power line with all the electric and magnetic interference there, and how powerful it is to cope with that when you use it together with that DRTK2 base station.
100%, thanks Stefan, yes. So there's a lot of magnetic interference around high kV power lines, and it can, with normal other drones, if you're not flying with RTK base station correction like this, can mess up with the compass of the drone, which can create problems for you. So this camera with the drone has got a smart track functionality. So this is a function that you can actually identify moving objects like people, vehicles and boats in the field of view that the camera is seeing, and follow it and take photos or video. This is obviously more helpful for public safety and security, but you can also, the laser distance measurement can also pin on top of the moving object to give you its coordinate as well as its range from the drone. This is obviously also very helpful in security. So there you can see it's monitoring that car driving off the road thing. So here was a local example as well, which I just tested. On the left we've got the visual RGB, on the right we've got the thermal infrared. Right. So then here I encourage you as well, please, to go and watch the full video of this is actually screen grabbed of some pylon inspections that I did out in the field with the drone. So you can see here the level of detail. You see there, you can see the number on that insulator, and there's the cables and the stock bridge dampers. It's just incredible. You can inspect the pylons and your conductors in very high detail. Again, here side by side is just the visual RGB and the thermal of the pylons. You can see those conductors are nice and cool versus the rest. And the purple, not the conductor, insulators, I mean, over there. with the rest of the temperature. Here's very interesting. I actually found a broken insulator ceramic disc. You can see over there, there's a broken disc on that insulator, or lost or whatever. And over here I measured 230 meters away on that connect. So you can inspect from 230 meters away with this drone, which is truly remarkable. Please go and have a look as well on the full video on the link here below. Then there's a function of high-res grid photos where you basically draw a square block over the area of interest, in this case the pylon, and you tell it to take high-res images for me at a zoomed-in level. So over here it's taking 20 images, so it moves to each one of those blocks, the camera, and takes very high resolution imagery for you to do your inspection work later on. Here's just an example of the temperatures that I found on the insulators. So on the left there you've got the thermal, on the right it's also thermal, but it's the white hot template color palette. So you can see there everything that will be white will be hotter than things that will be darker, more grey, not more to black. So you can see there on the right hand side I measured the road. The dirt road was 25.5 degrees Celsius, and then I measured the three measurements on the insulators, which were all three almost spot on the same 17.3 degrees Celsius. So obviously a hot insulator will be a problem for you. You can do the thermal inspections with this. And then we've got landing. Right, then for an in-depth first-person view of how to set up the DJI M300 RTK drone in the field, please visit our Optron YouTube channel. You can see the links in this slide. They will point you directly to where I did exactly these samples that I've shown you in this webinar, where I had a GoPro attached to my head, where I actually show you exactly where and how you switch on, where you set up the drone and fly the drone in the field.